Hello students, welcome back to Sneha Sopti YouTube channel, and today I will be doing a very important topic, and this will be really very helpful for the students from grade 11, 12, and further those who are preparing for JEE, NEET and the other competitive exams as well. The hybridization trick 1, how to calculate the hybridization of the carbon compounds, either they're aliphatic or aromatic. In any way the carbon is linked with the chain form, you can easily calculate the hybridization with the trick which I will be soon providing you now. And the hybridization trick 2 I shall be soon uploading on my YouTube channel for the inorganic compounds like nitrate ion, carbonate ion, and so on. And just a reminder, all those who are new to my channel, kindly subscribe my channel and do hit on the bell icon. And if you subscribe the YouTube channel, the name is Sneha Sopti, that is concerned to all chemistry videos. So without wasting much time, we shall move on. Now, you all know what is hybridization. That is why you have come up to understand the trick for calculating the hybridizations, because the MCQs which are based, that is really very important to crack on. And please do watch the video till the end so that we can do more and more examples and questions for you to answer. Now, what is hybridization? Hybridization means like if you are mixing any two things, the new thing which is being formed that has the characteristic properties of the first thing as well as the second thing. Same way as it in chemistry as well. What is hybridization? Sorry, it's only single I. A hybrid occurs when two things are combined and the result has characteristics of both. Similarly, whenever any atomic orbital, either it is of S type or it is of p type, they are intermixing to form a set of new orbitals. And why are they intermixing? So that their energy is minimized to increase the stability. So if I say what is hybridization? Hybridization is the intermixing of atomic orbitals of slightly different energies to form a set of new orbital with almost same energy. So in this case, if S and P orbital is formed, so the intermixing of the orbital occurs, and in this way, a new hybridized orbital is formed. Now we shall quickly move on to the tricks. And before moving on to the tricks, the sigma bond, which is represented by this, and the pi bond, which is represented by this. How many sigma pi bonds are present in single bond, double bond, and triple bond? Because if you don't know this, you cannot use that trick. I use single bond, I write double bond, and I write triple bond. In single bond, there is one sigma bond. There is no pi bond. In double bond, there is one sigma bond and one pi bond. Whereas in triple bond, there is one sigma bond and two pi bond. Please children, understand this thing. This is really very important to know that how many sigma and pi bonds are present in single bond, double bond and triple bond. You can see sigma is all 111 in all the three bonds, whereas there is 0 pi bond in single bond. In double bond there is 1 pi bond, and in triple bond there is 2 pi bond. Please do remember this thing. This is really very important. Now we shall proceed on to few examples and questions. Now if I started with the simple example first, C, 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 and here I use triple bond, and you know I've already made you aware in my previous video how to balance this H, because carbon is tetravalent, so there will be here no hydrogen, here will be one hydrogen, and here will be one hydrogen, and here will be one hydrogen. Now before we move on, I tell you the trick. What is my trick? You have to see the carbon, and the trick is sp3 minus number of pi bonds. Just remember this trick and crack all the questions. This is the trick, sp3 minus number of pi bonds. Now we shall first see how many pi bonds are there in each and every carbon atom. In this particular carbon atom, there's a triple bond. So in triple bond, there is 2 pi bond. Yes, it's single bond, no pi bond. In double bond, there is 1 pi bond. Here in double bond, there is 1 pi bond. So now if I see the calculation, this carbon has a triple bond. So you simply has to do sp3 minus the number of pi bonds, 2 pi bonds. So 3 minus 2 is 1. So this carbon is sp hybridized. Similarly, this carbon has also 2 pi bonds. So this will also be sp hybridized. Now check this carbon. This carbon is sp3 minus the number of pi bonds. Pi bonds are 0. So 3 minus 0 is 0 is sp3 hybridized. This carbon has 1 pi bond. So if I find the hybridization, it's sp3 minus 1, which comes out to be sp2 hybridized. Similarly, this carbon will also be sp2 hybridized. This carbon will also be sp2 hybridized. And this carbon will also be sp2 hybridized. So you only have to remember the trick, sp3 minus number of pi bonds. Yes. Now we proceed on to another question in which it is C triple bond, C double bond, C double bond, C H 3. Now it's 3, 1, 2, 3, and it's 1 hydrogen. All carbon valencies are satisfied. Now see, this carbon has triple bond. So quickly write down how many pi bonds are there? 2 pi bonds. In the single bond, so no pi bond. Here it is 1 pi bond and 1 pi bond. So if I calculate the hybridization of this carbon atom, it will be sp3 minus 2, sp3 minus number of pi bonds. So this carbon is sp hybridized. Similarly, this carbon is also sharing the triple bond. So it also has 2 pi bonds. So this is sp hybridized. This carbon has 1 pi bond. So sp3 minus 1, it becomes sp2. Now children, be very careful for this carbon. This carbon has 1 pi bond, 1 pi bond, because this carbon is sharing 2 double bonds on each side. My mistake, it will be CH2. So 2 pi bonds. So this carbon will be having sp3 minus 2. It will be sp hybridized. Children, my fault, it will be CH2 because there is a double bond here. So this carbon is sp hybridized. In this way, all the questions concerning to the aliphatic hydrocarbons can be easily solved. Now, if I move on to the aromatic one, the simplest I take up as benzene. This is the benzene. Now, this benzene has a formula C6H6 and each vertex, you know, that has a carbon. This C6 means each, this particular points have carbon and they all have a double bond. One double bond means 1 pi bond, 1 pi bond and 1 pi bond. Can you see each and every carbon atom is associated with 1 pi bond. So all the carbon atoms are sp2 hybridized. If I say sp3 minus pi bond. So this carbon is also, each carbon is sp2 hybridized, sp2 hybridized, sp2 hybridized, sp2 hybridized because they have 1 pi bond. And how do we come to know they have 1 pi bond? Yes, a double bond. A double bond contains 1 pi bond. We move on to some more numericals and some more questions. Now with this benzene compound, if I associate any functional group like carboxylic acid COOH, and the question comes that what is the hybridization of this carbon atom? It's very easy. You should know how to open up this bonding. We all know COOH is C double bond OOH. So if there's a double bond, there is 1 pi bond. And if there's a 1 pi bond, so this carbon will be sp3 minus 1, sp2 hybridized. Whereas all the other carbons also are sp2 hybridized. Remember the trick and you can crack all the questions concerning to the hydrocarbons. If I move on to this aromatic chain and I write C triple bond C. And what is the hybridization of this carbon? Hybridization of this carbon. Very simple. This carbon has a triple bond. So how many pi bonds? Two pi bonds. If there are two pi bonds, the hybridization technique is sp3 minus number of pi bonds. So sp3 minus 2 will be sp. Similarly, for this carbon atom, sp3 minus 2 sp. Whereas all other carbon atoms which are here, they are sp2 hybridized. Because sp3 minus 1 pi bond, so they are sp2 hybridized. Whereas the carbon which are on the tops, which are attached to the benzene ring, they are sp hybridized because of the presence of triple bond. I hope you have understood how the formation takes place. If I take up one more example of, there are two functional groups, ketone and a aldehyde. So what will be the hybridization of this carbon atom? Carbonyl group. This is a double bond. So 1 pi bond, sp3 minus 1 pi bond, sp2 hybridized. Similarly, there's a presence of 1 pi bond, sp3 minus 1, sp2 hybridized. Simple trick. Please remember, the only trick you need to remember is for the organic compounds is sp3 minus number of pi bonds, and with no failure you will be able to crack all the questions. Yes. Now I shall give you some 2 or 3 questions for you to answer so that I also get to know how much you have understood. Please balance the hydrogen on your own, and if you want me to do, I shall do it. No problem in that. This, before it's H and this H. And one more aromatic I give you, this benzene, and I attach a ketonic group and I attach a carboxylic group. Please let me know the hybridization of each carbon atom using this trick. So students, thank you for watching my video and continue watching, and please do not fail to watch my upcoming video which is based on the hybridization trick 2 for the inorganic compounds. Have a happy learning.